Now I would like to explain the second question. This is epicycloid. So how it reads: draw an epicycloid of circle of 40 mm diameter which rolls outside of another circle of 120 mm diameter for one revolution clockwise. Draw a tangent and normal to the curve at a point 95 mm from the center of the directing circle. Of course, tangent and normal we will do it later. First we will concentrate on epicycloid. How the epicycloid is? So you know epicycloid is a curve which is traced by a point on the circumference of another circle. So it is a circle, directing circle. This is another circle. When it rolls, let us say the P point is point P. When it rolls, the path traced by the P point is epicycloid. So it comes like this. So now for here this angle we have to find out. What is this angle? I told you in previous video, angle P is equivalent, angle theta is equivalent to R by R into 360. So what is this here? R is 40 generating circle, so it is 20. 20 by capital R is radius of the directing circle, so it is 60. So a diameter is 120, so it is 60 into 360. So the calculation we are getting 120 degrees. So this angle is theta is equivalent to 120 degrees. So no need to draw this entire thing. We just focus on this part only. That is enough. So we have to proceed. You just mark it. This point is O. So this point O I am marking here. I am taking at the bottom. This is O. So I am taking a horizontal line like this. So vertical line, very light line. So we have to take this angle is 120. This side is 60, this side is 60, like that we take it. 60, this is 60, because 120, no? It is 60 and other side also 60. Just 60, just measure it. It is 60 means bottom line 30. It is 30 bottom, it is 60. Here also 30. This is 60. Totally, you know, from center 60, 60. So it is 120 degrees. Now, what is the radius of the directing circle? It is radius is 120 mm. Say outside another of circle of 120 mm diameter. Radius is 60. So it is the 60 I am taking here. So it is 60. You just see here. Here also I am marking 60. Right. It is R is equivalent to 60. So I am marking this R is equivalent to 60. So it is actually when we are taking with this curve with compass, we are going to have a line like this. This line is like this. 2H pencil only we have to do it. Now on this another circle, this circle is rolling. You extend the line like this. You take the radius of the generating circle. What is the radius of the generating circle? It is 20 because the diameter is 40, so it becomes 20. You draw the circle by extending this 20 here. This is 20. Let us say it is C. So this is the radius. It is 20 mm because it is 40 no diameter 20. So draw the circle like this. Like this you have to do it. So it is the diameter of 40. So now we have to draw the. It is C. Now we have to divide this circle into number of divisions. So how many number of divisions? Generally we are handling. We can do 12 divisions or 8 divisions like this. I am taking this 12 divisions here. So how we have to take it? Because it is 360 degrees for every 30 degrees. This is one. This is another. This is 30, 30, 30, 90. Then extend 30. Then extend 30 like that. Then here also extend it. Let us say I can mark this as 1, 2, 3, 4, 5, 6. Then extend it. And then this is 6. This is 7. Just see. Then just see 8. Then 9, 10. Now you just see for every 30 degrees. This is 30 degrees, 30 degrees, 30 degrees, 90 this quarter. Then 120, 150, 180. 270. Likewise, we just make it 12 number of divisions. So now this is the sixth half division. We extend this line likewise this. We extend the sixth line, or otherwise we can do from here extend it. So 40 extend it because total diameter of the circle is 40. So take O to 6 and draw the line. O to 6, draw the line. We are going to have this curve like this. In this we have to accommodate the epicycloid. So now we have to draw we have to divide this 120 into 12 divisions because the circle is divided into 12 divisions. This also we have to divide into 12 divisions. So how we are going to have it? For every 120 degrees, no, 12 divisions. For every 10 degrees, you can have the division. So this is the first division, like this. First division. This is the first division. Second division. Third division. Fourth division. Fifth division. Sixth division. Likewise, I can mark here to understand you. 1, 2, 3, 4, 5, 6. Then make it like this. Seventh division. This is the seventh division. Eighth division. Ninth division. 10th division. 11th division. 12th division. Now these are too expensive level we are doing it. Now we have to draw the lines which are going from different points on the generating circuit. See here, from 1 to take 0 to 1 up to here. To draw the arc with compass. With compass point, we just make it with compass. You have to draw it. Even you are extending it, even it is touching level. Then take 0 to 2 to draw the arc. So when we are bringing back, it is also touch 10. Then 0 to 3, take with compass, just draw the arc. Right? 0 to 3, when you are extending back side, it is touching 9. That's nice. 0 to 4, when it is touching 7 back side. 8 back side. It is touching 8. Right? Draw it. Then 0 to 5, when it is touching 7 back side, draw the arc like this with compass. All distances we are using. Now, path of the center lines we will identify. It is C. It becomes path of the center lines is not following 3 like as earlier video because it is a uniform circle following an horizontal surface. Here, path of the center lines is different from 3. So, draw the path of the center lines. You take O to C, draw the line which is going through C. So, now I am marking all the points. See here, it becomes C1 because the path of the center line is C1 which is there on 1. It is C2, it is C3, it is C4, it is C5, it is C6, it is C7, it is C8, C9, D0, or C9, C10, C11, C12 like that. Right? Now we are going to have P1. How we can have the P1 point? To have P1, take the radius of the generating circuit. Take R is equivalent to 20 mm because the radius of generating circuit is 20. Cut the line going through 1. Line going through 1 from C1. Just see. You take from C1, this is the C1. Cut the line which is going through 1. See here, this is the line which is going through 1. Back side it will come. You just cut here. So it becomes P1. This is P1. Now P2. Take the distance R is equivalent to 20 from C2. Cut the line which is going through 2. What is the line which is going through 2? This is the line which is going through 2. So somewhere here we are getting P2. Yes, I will tell you, to have P2, take the R is equivalent to 20. cut the line which is going through 2. This is the line which is going through 2. So somewhere here we are going to have P2. Then P3. So we can have it. Here the R is equivalent to 20. Cut the line which is going through 3. This is the line which is going through 3. Somewhere here we are going to have it. P3. Likewise extend it. Let us say we have to have P4. Cut the line which is going through 4. P4. Then cut the line which is going through 5. So we are getting P5. Then P6. Cut the line which is going through 6. P6. Then same you repeat it for 7th point. P7. 8th point. P8. So P8. P8. 9th point. Cut the line which is going through 9. P9. 10. Cut the line which is going through 11. 10. P10. 11. We are getting P11. Then we are getting P10 like this. We are join all the points for root cut. So just have it. Join from P1, P. We have the curve like this. Just to understand you, I am not considering you to this very closeness of these points, because when you are taking the drawing sheet, you are getting all the points very neatly. So this is how we are going to have your curve. P1, P2, P3, P4, all that we have to join it very neatly. This is how we have to draw this curve. This is epicycloid. Now this is a generating circuit. And this is the directing circle, not required. Now we have to draw the tangent and normal at the distance of 95 mm from the center of the directing circle. You just take 95 from O, cut somewhere here. That means at this point we have to draw the tangent and normal. This is 95. This point is 95. Please remember. Yeah, this side or this side, any side you can take. Now from Q, take the distance of the radius of the generating circuit, 20. Cut the path of the center line. Path of the center line is this now. Cut somewhere here. Wherever we are getting, cut here. Let us take some yes. Now draw S to O, join it. S to O, join it. Right? When you are joining, it is cutting the path of the directing circuit. This is the path of the generating circuit, it is cutting. So this is the path of the directing circuit, it is cutting. Let us say it is O. Now we have to join Q to U, which is a tangent normal for this curve. Let us say M and S is normal for this curve. Perpendicular to this, at this particular point, make your milligram perpendicular to this point. At this point, you can make it. This is a tangent, T, D dash. You write it. M and S is normal, T, D dash is tangent, and you write it epicycloid. Epicycloid. You write it at the bottom. M and S is normal. You write it just, and T, D dash is tangent. Thank you.